In the grand tapestry of the cosmos, our existence is but a fleeting whisper. A whisper that echoes across the infinite expanse of the universe, a realm so vast and complex that it defies comprehension. It's a place of celestial bodies, stellar phenomena, and cosmic mysteries that have captivated the human mind for millennia. Among these enigmas, the creation of our very own solar system holds a special place. It's a tale as old as time itself, yet it is one that continues to bewilder even the most brilliant minds. The story of our solar system's birth is a testament to the universe's grandeur and its uncanny ability to create order from chaos. Imagine, if you will, a place devoid of planets, moons, and the sun as we know them. A place where only cosmic dust, gas, and the raw materials of creation exist. This was our solar system's humble beginning, a vast nebula waiting for the spark of creation. In the midst of this cosmic wilderness, the seeds of creation were sown. As the universe continued its inexorable march, these seeds would undergo a transformation of cosmic proportions. From the humblest of beginnings to the grandeur of celestial bodies, this is the story that we are about to embark upon. But how, you might ask, did this transformation happen? What sequence of events led to the creation of our solar system? The answers to these questions are shrouded in the mists of time, obscured by the veil of billions of years. But fret not, for we are about to embark on a journey back in time, a journey that will take us to the very beginning of our solar system's existence. The birth of our solar system, an event cloaked in cosmic mystery, is a tale that begins over 4.6 billion years ago, a tale that weaves together the threads of science, cosmology, and the indomitable spirit of discovery. A tale that, despite its intricate complexity, is our story. The story of our place in the cosmos. Our story commences in the heart of a nebulous cloud, an immense body of gas and dust. This celestial entity, known as the solar nebula, is the birthplace of our solar system. A vast expanse of cosmic soup, it was teeming with hydrogen and helium, peppered with heavier elements such as carbon, nitrogen, and oxygen. In this nebula, something extraordinary began to happen. The forces of gravity, ever present, began to pull the gas and dust together. The nebula, once a loose, shapeless entity, started to collapse under its own weight. As the nebula contracted, it began to spin faster and faster, like an ice skater pulling in her arms. It's a principle of physics known as the conservation of angular momentum. In the very heart of this spinning, collapsing nebula, a protostar began to form. This embryonic star was incredibly hot and incredibly dense. As gravity pulled more and more matter into the protostar, its temperature and pressure rose to unimaginable levels. Simultaneously, the nebula's rapid rotation caused it to flatten into a disk shape, with the protostar at its center. This is the circumstellar disk, the birthplace of planets. The disk was a maelstrom of gas and dust, swirling around the protostar in a cosmic dance. But this dance was not chaotic. Patterns began to emerge in the disk. Concentrations of matter began to form, growing larger and larger. These were the seeds of the planets, the beginnings of a process known as accretion. As the protostar continued to grow, it began to shine, its light pushing away the remaining gas and dust in the disk. This was the birth of our sun. And around it, in the remnant disk, the planets began to take shape. Thus, in the swirling dance of matter and energy, the stage was set for the formation of the planets. In this cosmic nursery, amidst the swirling dust and gas, the seeds of planets were sown. Our journey begins with a process known as accretion, the very first step in the birth of planets. Picture a cosmic cloud of dust and gas, swirling and coalescing under the influence of gravity. Each particle, no matter how small, exerts a gravitational pull on its neighbors. Over time, these particles drift together, sticking to one another like cosmic Velcro. The result? Larger and larger clumps of matter that we call planetesimals. Now, these planetesimals aren't quite planets yet, they're more like planetary toddlers, lacking the size and structure of a fully grown planet. But they're on their way, growing larger and more complex with each passing cosmic moment. As these planetesimals continue their growth spurt, they start to experience internal changes. Just as a caterpillar metamorphoses into a butterfly, planetesimals transform into protoplanets. This transformation is triggered by the intense heat and pressure at their cores, causing the materials within to differentiate. Differentiation is a process where denser materials sink to the center and lighter materials rise to the surface. This process is responsible for creating the layered structure we see in planets today: a dense core, a mantle, and a crust. This differentiation process also leads to one of the most fascinating aspects of planet formation: the division into terrestrial and gas giant planets. Protoplanets close to the Sun, like Earth and Mars, become terrestrial or rocky planets. Their volatile gases are stripped away by the Sun's powerful solar winds, leaving behind a rocky core. Meanwhile, those further away, like Jupiter and Saturn, become gas giants. They're far enough from the Sun to hold onto their gaseous envelopes, forming massive planets dominated by hydrogen and helium. And so the planets, each with its own unique story, were born. From the humble beginnings of cosmic dust and gas to the majestic celestial bodies we see today, each planet's birth is a testament to the awe-inspiring processes of the cosmos. Our newly formed solar system was not a tranquil place, but a stage for a celestial cataclysm known as the Late Heavy Bombardment. Picture a cosmic shooting gallery with asteroids hurtling through the void, colliding with the young, vulnerable planets in our nascent solar system. This was the reality during the Late Heavy Bombardment, a period of increased asteroid impacts that spanned around 200 million years, starting approximately 4 billion years ago. During this time, the inner planets of our solar system, Mercury, Venus, Earth, and Mars, were subject to a relentless onslaught of asteroids. These celestial bodies, the debris left over after the formation of the solar system, were flung towards the inner planets by the gravitational forces of the outer gas giants Jupiter and Saturn. This bombardment had a profound effect on shaping the surfaces of these planets. The immense heat and force generated by these impacts led to the creation of enormous craters, many of which are still visible today. But it wasn't just about destruction. The impacts also delivered precious elements and compounds, including water, to these planets. This could have played a crucial role in creating the conditions necessary for life on Earth. The gas giants, Jupiter and Saturn, played a pivotal role in triggering this period of bombardment. Their immense gravitational pull disturbed the asteroid belt, a ring of debris located between Mars and Jupiter, causing asteroids to veer off their orbits and hurtle towards the inner planets. This celestial billiards game continued until the orbits of the gas giants stabilized, bringing an end to this tumultuous period. The Late Heavy Bombardment was a time of chaos and creation, a period that reshaped our solar system and possibly set the stage for life as we know it. It serves as a stark reminder of the dynamic, ever-evolving nature of our universe. The scars of this cosmic bombardment are still visible on the surfaces of our planets, a testament to their violent past. From the fiery birth of a star to the formation of planets, our solar system has endured an incredible journey. The tale of our solar system is one of cosmic resilience and transformation, a ballet of celestial bodies dancing to the tune of gravity. It began around 4.5 billion years ago in the heart of a giant molecular cloud, a spark, a gravitational collapse, and voila, our sun, that fiery beacon of life, was born. Around this newborn star, a protoplanetary disk spun into existence, a cosmic carousel of gas and dust. From this swirling chaos, the planets began to take shape. They coalesced from specks of dust to pebbles, from pebbles to boulders, and from boulders to planets. The birth of the planets was a time of chaos and violence. Collisions were frequent, and the impact scars are still visible on many of the planets and moons today. Then came the Late Heavy Bombardment, a period of intense meteorite impacts that reshaped the faces of the planets and the moons. Fast forward to today, and we find ourselves in a relatively calm and stable solar system. Our sun, a middle-aged star, continues to burn brightly, providing the energy that fuels life on Earth. The planets, each with their unique characteristics, orbit the sun in a delicate balance. Yet our understanding of the solar system is still evolving. By studying its formation, we gain insights into the processes that could be happening in other star systems. We uncover clues about the possibility of life elsewhere in the universe. And so our journey of discovery continues. We probe the depths of space with our telescopes, send probes to other planets, and dream of setting foot on other worlds. As we delve deeper into the cosmos, we are not just exploring outer space, but also our place within it. In the vast expanse of the cosmos, our solar system is but one story among billions, each with its unique tale of creation and evolution.